Okay, before we look at distant vector routing protocol, let's look at metrics again. Okay, we covered metrics in the earlier chapter. Okay, so what is metrics? Metric is basically a measurable values that is assigned by the routing protocol to the different routes. Okay, in short, it's just the cost. The cost of using that path to reach the destination. So in RIP, okay, we use the cost called hop count. Hop count. Okay, so basically it's how many hops away to reach the destination. Okay, so cost, okay, just bear in mind, cost, the higher the cost, the worse is the route. The lower the cost, the better is the route. Okay, so routing protocol will use the path with the lowest cost and use it as the best path to reach the destination. So for RIP, the lower the hop count, the better, because the destination will be nearer. Okay, let's look at distant vector routing protocol. Some of the characteristics. Okay, basically they will share updates, routing updates between the neighbors. The router will share the routing updates. They do not have the entire network topology. That's why it's called a distant vector routing protocol, compared to link state where you have the entire map. Okay, some of the distant vector routing protocol send periodic updates, okay, to a broadcast address, even though the topology have not changed. Okay, that means they keep on updating their routing table to other neighbors. Even though nothing have changed, they will just keep on updating and updating. Okay, and this update actually consume bandwidth because the neighbor need to read the update, realize there's no change, and throw away the packets. So this update will actually consume some of the bandwidth and also the CPU for the neighbor to read the packet. Okay, RIP version 2 and ERGRP have improved because they use multicast address instead of broadcast address. Okay, this is an advantage because, okay, for example, so say this is a switch and it's connected to different PCs. Okay, this is router, this is router. If you're using RIP version 1, okay, the RIP updates, okay, are sent as a broadcast. Okay, that means all the devices in the network will receive these RIP updates. Of course, PC, they do not need this update because they are not routers. So the PC will read the packet and then throw away the packet because they do not need the updates. And these updates are sent every 30 seconds. So this update will be sent to all the PC, which will consume the bandwidth and also consume the CPU of the PCs, because they need to read the packet and discard it. Compared to RIP version 2 ERGRP, because it uses multicast address, RIP packet will not be sent to the PCs. It only sent to the RIP routers. Okay, because only the RIP routers will belong to the multicast address for RIP. Okay, so this will save you the bandwidth and also the CPU. Okay, one more advantage by ERGRP is they will only send updates. Okay, sometimes we call a triggered updates. Okay, that means the update will only be sent when there's any change to the topology. No change, no update. Again, this will save you bandwidth, this will save you CPU utilization. Unlike RIP. Okay, RIP even version 2 will keep on sending periodic updates even though nothing have changed. Okay, what routing protocol does distant vector protocol use? Okay, what algorithm do they use? Okay, for RIP, they use the algorithm Bellman-Ford algorithm. Okay, this algorithm helps them to determine the best path to reach the destination. For IGRP and EGRP, they use the Cisco algorithm, okay, diffusing update algorithm. Okay, in short, we call it a dual routing algorithm for them to calculate the best path to the network. Okay, let's look at some of the characteristics and compare between the different routing protocol. Okay, let's look at RIP version 1 and RIP version 2. Okay, the main difference is RIP version 1, okay, is a classful routing protocol. Version 2, classless. Okay, because of that, okay, for version 1, they do not support BLSM, CIDR, route summarization, okay, and they do not have this authentication. Okay, authentication is a security feature, okay, that, okay, between two RIP routers, they can authenticate with each other. Okay, if there's a hacker who want to connect their routers to the RIP routing domain, okay, they will not be successful because they will fail the authentication. So it's a security implementation and it's not supported by RIP version 1. Okay, another difference in RIP version 1 compared to RIP version 2 is RIP version 2 uses multicast address, while RIP version 1 uses broadcast address. Okay, both routing protocol uses UDP port 520 to send their packet. Okay, another one is there's a 15 hop limits in RIP version 2 and also RIP version 1. 15 hop limits means that let's say there's a series of routers, and so on. The number of routers from one end to the other end, a maximum can only go 15 hops. Anything that's more than 15 hops is considered unreachable. That means your network cannot be too big. The administrative distance is 120. Again, if you remember administrative distance in the previous chapters, it means how trustworthy is this routing protocol, how much the router trusts this routing protocol. For RIP is one of the highest, it's 120. OSPF 110, EIGRP 90. Static route is 1 and directly connected network is 0. RIP-NG is used for IPv6 and it's also based on RIP version 2. So RIP-NG is used for IP version 6. How about IGRP versus EIGRP? Again, IGRP is the older version of EIGRP. IGRP uses broadcast, EIGRP uses multicast. And IGRP is classful and EIGRP classless. Again, that's why IGRP don't support VLSM, CIDR, route summarization, and it also doesn't support authentication. While EIGRP support all of them. Another, again, one of the main features of EIGRP is they use trigger updates. That means the updates are only triggered when there's a change in the topology. And it's bounded. Bounded means it's bounded within the multicast address. And also, you only send the updates to the router who needs to know the change. If that router do not need to know the change, you will not send the update. Again, it's helped to save the bandwidth. EIGRP also use the hello keep alive mechanism between the neighbors. They will just send hello to each other to make sure that they are alive because now it's a trigger update. So if after a while there's no updates, right, they need to use some kind of mechanism to make sure that the neighbor is still alive. EIGRP also support and maintain a topology table of all their neighbors and the routes advertised by the neighbors. It supports rapid convergence, so it converges much faster than RIP. And it also supports multiple network layers. So network layer will include your IP and other type of network layer. For example, the older IP, IPX, and AppleTalk. But right now, of course, IP is the most frequently used protocol in the network layer. That's all for this video and for this week's lesson. Hope you all enjoy your public holiday and I'll see you next week. Remember to do your lab 4 and there will be a video on lab 4. So do review the video if you have some problem doing the lab 4. So see you all guys next week. Bye.